Afternoon to everyone. Uh, Today we are going to discuss about the Oppenauer oxidation. Oppenauer oxidation is nothing but, as I wrote the definition, it is the conversion of the secondary alcohols to ketone by the reaction with the acetone. That is in the presence of catalyst. What catalyst we are using here means tertiary butyl oxy aluminum. This is very important, which is used as the catalyst. Okay, it will be finish its work, conversion work from the secondary alcohol to ketone, and as it is, it will be leaving the reaction. Just see the reaction, you will become to know. This is the secondary alcohol. When it react with the acetone, that also in the presence of tertiary butyl oxy, that is 3 moles aluminum. It is called as the tertiary butyl oxy aluminum. It is helpful for the oxidation of this secondary alcohols. Then what it will be produces? Just see, alcohol, what you are observing, R1, R2, then this alcohol converted to the ketone. Just see the difference. This is the difference. Alcohol converted to the ketone in the presence of what? Tertiary butyl oxy aluminum. Remember that. Along with that, then itself it will be converting into the alcoholic form. We should not bother about this because this acetone, it is sacrificing its life by converting into the alcoholic form. Okay, then what purpose we are using here? Conversion of the secondary alcohols to ketone in the presence of what? Tertiary butyl oxy. How many moles? 3 moles tertiary butyl oxy aluminum, because this will be play the vital role in case of mechanism of action. Just remember this. Okay, this is the Oppenauer oxidation. Now I will show you the mechanism. Just see the mechanism of action for this. What was the reaction? Initially we are taking the secondary alcohol. Now we will take the secondary alcohol. Okay, then what is the catalyst we are using in case of this? Butyl oxy aluminum. Here we are taking the 2 moles. But initially what we are observing? In case of main reaction, 3 moles are there. Okay, catalyst is the 3 moles. Here I will write. This is actually what we are using. How many moles? 3 moles. But here we are taking the 2 moles only. Remaining 1 mole also it will be come into the picture. You can be see later. This is what? Tertiary butyl oxy aluminum. As we know, this oxygen, it is having the pair of electrons. Remember that. Oxygen always having the extra pair of electrons. This electrons, extra pair of electrons, motivate this catalyst to come and join. Because you can see here it is having the positive charge. Then easily it can attack on this. Then what it will be form after attacking? It will be joined with this catalyst. This reaction is possible, either side it is possible. Now R1, R2, here you can see what is there? Hydrogen is there. Okay. Otherwise I can write this hydrogen this side. Okay. Here extra pair of electrons are there, I told you, on the oxygen, that will be joined with this catalyst. Then what it will be formed here? Al, here oxygen, that is tertiary butyl. How many moles? 2 moles of tertiary butyl oxy aluminum. Okay, it formed the complex with the tertiary butyl oxy aluminum. Total how many moles? 2 moles. This is the product 1. Now you can see how many moles here? 2 moles. One more mole is there extra. Total how many? 3 moles. From the 2 moles we are using to be form the complex with this. Another 1 mole where it is? Just see. Another mole I will write here. This is 1 more mole. 2 moles of tertiary butyl oxy here. 1 mole, 1 more mole is here. Then what it will be do? It is having the negative charge. Okay, 2 pairs of electrons it is having. That's why easily it is going to abstract this proton. Remember this. It is going to abstract this proton. After abstracting proton, what it will be formed this one? After abstracting the proton from here, you can see that it's leaving the pair of electrons here only. Don't be confused. Only hydrogen it is taking away. Then after taking away hydrogen, what it will be formed? O. Then what is here? Hydrogen. It is combined with this. Tertiary butyl alcohol it is formed. Okay. Leaving the pair of electrons here only. Then this molecule, product 1, this is converted to the product 2. What is that product 2? You can see R1, R2. Here hydrogen is not there. Instead of that it is getting the pair of electrons. Okay, because only hydrogen it is taking away. Then remaining thing is what? Aluminium. Then what is there? Oxygen. Just see, tertiary butyl. How many moles? 2 moles. This is the product 2. Just hydrogen is left from here. Now see, next what happened? It is highly unstable, this molecule. It have to believe this. It have to believe this means where it should go now? Here only acetone will be come into the picture. Then what happens here? This whatever the tertiary butyl oxy aluminum is there, this tertiary butyl oxy aluminum, it is going to occupy the acetone, react with the acetone, CH3, CO, CH3. Here what it will be having? Extra pair of electron it is having. It means easily it is accept this tertiary butyl oxy aluminum. It will be accept that one means what happen here? This pair of electrons going to combine with this. Then it is going to be form the new bond with tertiary butyl oxy aluminum. Okay. This is the what happened here? It is leaving this. It is leaving means this pair of electron going here. Because it is going away without taking this bond, means without taking this pair of electrons. Okay. Then what will be formed here? This product will be converted to R1, R2, here oxygen. Already it is having extra pair of electrons. I will write here. Then this bond it will be move here, means this pair of electrons it will be move here, means it forming the double bond. Okay, because it is leaving pair of electron, that is helpful for the formation of double bond. Then what it will be formed here? Then what it is called? Ketone. What is the definition? Conversion of the secondary alcohol to ketone. What we achieved. Then next what happened here? Acetone is there, no? We should not leave like that only, this is to this acetone. This acetone, what it is doing? It is occupying, it is interacting with this catalyst. Then what it will be formed, that one? Acetone. Then here, oxygen. There is no double bond here because it is coming to pair with this, means this double bond it will moving here. In sense what? Easily you can understand. It will be attack on the oxygen. It means it utilizing this pair of electrons. Okay, here extra pair of electrons. Then oxygen valency is how much? 2. That's why this pair of electron in the form of double bond move to the oxygen. Then what it will be formed, you can see? O. New bond it is formed here. Al. Tertiary butyl oxy. How many moles? 2 moles. Here extra pair of electrons are there. That extra pair of electron, what it will do? Already we know that there it forms the tertiary butyl alcohol. Okay. Now this hydrogen, it moves here because this is the O minus H plus. Then this proton, it is taking away by the which one? This acetone. Okay. Then when it will be take this hydrogen, it is converted to what? It is converted to what? Acetone. Now this one converted to the O. This hydrogen come and joined here. Secondary alcohol react with acetone. Acetone is the ketone. In the presence of what I told? Tertiary butyl oxy. How many moles? 2 moles aluminum. Sorry, 3 moles here in shell. Tertiary butyl oxy aluminum. What the product it is produces? Alcohol converted to the ketone. Then this acetone it will be converted to the alcoholic moiety. Just see. What purpose we use this one? Conversion of the secondary alcohols to ketone. That's our main motto. Now see, secondary alcohol reacting with the 2 moles of tertiary butyl aluminum, extra pair of electron joining with this catalyst. Okay, then it is forming the product 1. Then this hydrogen, you might be know, this one becomes plus. Why it is become plus? Oxygen valency is 2, but here it is 3. 1, 2, 3. Then it have to be go away this hydrogen. This hydrogen abstracted by the 1 more mole of, here 2 moles only we took, 1 more mole of tertiary butyl oxy moiety. Then see, it is converted to the alcohol. Okay. Now after converting to into the alcohol, what? You can see here it produces the product 2 along with the catalyst. Now this will be react with the acetone. Then here this product, now it is highly unstable product 2. Then what it will be do? It is having the catalyst, no? That catalyst giving to the acetone. When once it will be give catalyst to the acetone, what happen here? This pair of electrons coming and it is forming the ketone. Like this. Double bond it is forming. Then it's burden off from his shoulder. Which one? This product 2. By giving the catalyst to the acetone. After giving the catalyst to the acetone, it's given this product. Acetone with catalyst. Catalyst from where to where it will jump? It jump from the ketone alcohol to the ketone. That's why what happened here? This whatever the double bond is there, it will move here because it is coming here on the oxygen. That's why this bond, it will be, this pair of electron move, they should be have to be move here. They move no pair of electrons, extra pair of electrons. Now see, now what happened? This oxygen having the pair of electron. Then what it will be do? It have to be abstract this proton. After abstracting the proton, then you might be see this moiety, particularly tertiary butyl oxy, it will be joined with the this moiety. 2 moles of tertiary butyl oxy, here 1 mole of tertiary butyl oxy. Then total how many moles? 2 plus 1, 3 moles. See, 3 moles of tertiary butyl oxy. It's going away after finishing the reaction. What reaction it will be finished? It converted from the secondary alcohols to ketone. Okay. This acetone, just it is the balika bakra in this case. It's sacrificing itself. Only for what purpose here it is? It's taking only the catalyst. It's consuming. That is the reason when it will be take the catalyst from this alcohol to that ketone, then only it will be converted into the ketonic form. Which one? Secondary alcohol to ketone. This conversion of secondary alcohol to ketone only, what we are calling Oppenauer oxidation. Then we will be discuss the applications of this. What is the main reaction ours? Conversion of the secondary alcohols to ketone. Means first reaction, first application is what? It helpful in the conversion of secondary alcohols to ketones. Yes, already we discussed that. But another greatness of this reaction, main application of this one, for example, you might be take. This is the example I am giving. This is what now? Secondary alcohol. Secondary alcohol, what it is having? It is having the double bond. See the importance of this Oppenauer oxidation, advantage of this Oppenauer oxidation. It converts this secondary alcohol to the ketone, CH3CO, CH double bond, CH, CH3. See, it is converted to the ketone. Alcohol converted to the ketone by the oxidation. But see, without disturbing the double bond. This is very important. Without disturbing the double bond, it converted to the secondary alcohols to ketone, but it is not showing any effect on this unsaturation, means on the double bond. That is the important thing, important main advantage of this Oppenauer oxidation. You might be understood this. Third application, you might be see the structure of the cholesterol. I am not going to write the entire structure. Okay, cholesterol, here it is having in the form of alcohol. This is the cholesterol. Cholesterol having the alcohol. See, with the help of Oppenauer oxidation, this alcoholic group converted to the ketonic group. See, alcoholic group converted to the ketonic group. With the help of what? Again, same catalyst by the oxidation process. Which oxidation? Oppenauer oxidation by using the same catalyst. What catalyst we used? tertiary butyl oxy aluminum. Okay, here also tertiary butyl oxy aluminum. Okay, then the another thing is that cyclic alcohols. This is the cyclic alcohol. Cyclic alcohol also secondary alcohol only. With the same means what here? The cyclic alcohol converted to the ketone, cyclic ketone. Alcohol converted to ketone in the presence of same tertiary butyl oxy. How many moles? 3 moles aluminum. See, cyclic alcohol converted to the cyclic ketone with the help of what? Open your oxidation by using the tertiary butyl oxy aluminum. See, all these are the applications. Here also you can see in case of cholesterol, this alcohol converted to the ketone. But see here double bond present in this position, but in this case present at this position. Only movement it will be shows. Double bond it will be moved from here to here. But it is not going to remove the double bond. That also happens. Here see, no movement, no disturbance, double bond as it is like that only. But here the movement of the double bond takes place, but it is not going to be saturated the double bond. That is the main importance advantage of this open your oxidation. Thank you very much.